Everybody, thank you for joining us today for October Meetup. We've done a joint meetup for the AWS users group in Louisville and our Cloud Native Lou. Since we're going to be talking about something that's cross-section, we're going to be talking about the AWS CDK and how to use it to help deploy and run applications on Kubernetes. So I think the latest update that I really saw that is cross-sectional that everybody will probably be familiar with is EKS supports 118 now. So if you're running any clusters that have old versions, you probably want to go and look to updating running 118. Also, we have HashiCorp put out 2 brand new projects. So they put out, I think it's Boundary. So using session management and then Wayfair or Waypoint. I can't remember exactly off the top of my head. I should have those down in my notes. But it's a new way for them to do build, release, and deploy for your applications. So that'll be interesting to dig into. Both are open source. So just another standard for us, another tool for us in our toolbox. So that'll be fun to look at. Because I know I do a lot of Terraform work, and I'm really interested in learning about CDK. So with that, I'm going to go ahead and hand it off to Matthew, unless anyone has any projects that they want to talk about, anyone's looking to get hired or hiring. Now's your time. Speak now, forever hold your peace. Until next month. No? All right. Well, Matthew, the floor is all yours. Let me check to make sure that you can share. Yep, you can share. And with that, I'll let you do the URL introduction.
Excellent. Thank you, everybody, for coming. As you said, my name is Matthew Bonig. A couple of URLs that I posted in the chat here in Zoom for you, and I'll try to get them into the meetup as comments afterwards, or at least one of them. The first one is for meet.ps. This is just a simple way for me able to do polling. It looks like most of you have already answered it, so great. Thank you for doing that. If you have any questions for the Q&A towards the end, go ahead and put in the questions there, and we'll address them at the end. Feel free to interrupt if I'm just completely losing you, though. It's a small enough group. I don't think that's going to be a problem at all. The second link is to the actual slide deck that we're going to be covering. So if you don't want to wait around for me to hit the next button, or you want to reference these slides when you're all done, by all means, go ahead and do that. No problems there. So we'll get started. And let me go ahead and get this going. All right, so the cdk8s is going to be the topic for tonight. It is a project that largely came out of AWS as a offshoot of the AWS CDK. Looks like most of you are familiar with the CDK, but in case we're not, the AWS CDK stands for the Cloud Development Kit, and it is a software development tool, an API that was produced and managed by AWS that takes a API idea called a construct and allows you to create all these different constructs. These constructs represent either small bits of infrastructure or very large bits of infrastructure, and allows you to create them and wire them together and set all the properties in a much more intuitive way and a much more easy way than trying to do static definition files like JSON or YAML. Because the API is available in Python, JavaScript and TypeScript, .NET and Java, you get strong typing. You get to use the language of your choice rather than having to sit there and constantly reference back to YAML reference documents and things like that. It's been a huge success over in the AWS community. A lot of people have really loved it and adopted it. I'm a big proponent of it. I've been using it for about a year now in my job, and I honestly couldn't see doing my DevOps work in AWS without it. The concept is very simple.
That's a pretty big statement, pretty bold statement.
You know, there was a project that I was on last year where we were dealing with very large scale deployments, and it was very microservice intensive. So we had a lot of resources we were deploying. So it came in very handy for being able to define those things. So
right, I'm excited to see it.
So after they had the CDK and that was all working well, they started to realize that the design paradigm, the API itself, actually lends itself to not just defining AWS resources, but pretty much any sort of really infrastructure as code. So in the course of this year, we have seen two major offshoot projects come out of it. One is Terraform CDK, which takes the idea of a multilingual API based on constructs, and the rendered output is Terraform. So you can continue using Terraform for doing all of your infrastructure as code. That project just gives you an easier way to generate that Terraform. And then the cdk8s, which gives us a much easier way to generate out our Kubernetes resources. So without further ado, let's kind of regroup onto what is the current state of Kubernetes and their infrastructure as code, because Kubernetes is naturally an infrastructure as code system. It's not something where a infrastructure as code service or platform was built on top of it. It was inherently part of Kubernetes from day one. And we see that represented in basic Kubernetes manifest files. These are static YAML files that you may download from a third party that defines things like either deployments like we see here, or custom resource definitions or things like that. You run a very simple kubectl apply command, and these things automatically get spun up and created within your Kubernetes cluster. Very easy to read, generally easy to manage, but they really fall apart quickly because they're not dry. If in the case here I have this deployment and I want to make all 30 of my application teams be able to deploy out Nginx reverse proxies, if I was going to use this process for doing it, everyone would have to copy and paste a YAML file. And then if all of a sudden you decide one day, oh, well, we need to get resource management built into these or affinities or things like that, now you're changing 30 copies of a file, and they're incredibly hard to manage long term. Now, the next step up from this is typically Helm charts. And if you've ever worked with a Helm chart before, then what you're seeing here is probably going to be pretty straightforward, or it's going to look fairly familiar. You start with a basic YAML file, and then you start replacing out static values like a deployment name or a chart name or labels or annotations or anything else like that with this tokenization that gets executed by Helm to generate a static YAML file. And the problem with this is that it's a good first step, but it again starts to fall apart when you start talking about very large scale in either the size of the Helm chart or the scale of your organization. So if I start looking through here, at first, these things are pretty nice. So I'm just saying, go ahead and grab out this RabbitMQ full node. But by the way, this is a direct copy of a Helm chart for the RabbitMQ service from the Helm stable repository. And most of these things are pretty straightforward. I'm just setting them to direct values. But then I start to get into these things like if statements, and these aren't too bad, but I don't write in Go code from day in and day out, and this is Go templating. So I kind of always have to go back to the syntax of Go and make sure that I get all of my sort of conditionals right and things like that. And then you start to really get into some painful areas, like where you want to reference a variable that was handed to this template, something that's going to change from deployment to deployment. But then you have to specifically say that you want it rendered out in YAML. And then you also have to be real specific about indentation and know where you are in your indentation of this YAML file. And as this thing goes on and on, you end up with a file that it's not great to maintain. You run into a lot of rough edges on it. You run into situations where you make one small change and all of a sudden everything breaks on you, and now it's a pain to kind of go through and debug. You can test these templates, but most of the time that's probably just going to be running the Helm template command to try to generate out the resulting YAML. Oh geez, my thumbs up is way off again. This is a weird bug in this slide deck. I don't know why. So you generate out your template file, and then you're either going to run some sort of automation that you've written yourself to test this thing, whether it be basic regex, or maybe you go ahead and load it into a process that does some testing, but there isn't really anything built in directly into the ecosystem. So yeah, Helm templates are really easy to kind of start working with, but over a long term, it gets to the point where a lot of organizations I've worked with, they just don't want to maintain these things. And the testing on them is very superficial, so you always end up integration testing. So now all of a sudden, within a build process, you have to have a running Kubernetes cluster somewhere to try to deploy these things and then do full integration testing, and it's a big pain. All right. So the other big detractor to these things is they're not really, you can't really refactor them. So if we go back to our RabbitMQ, you know, there might be a section of variables in here that you're going to want to drop in across a couple of different Helm charts. There's no real good, easy way of taking these things and, distributing them around in the same way that we like to refactor our code and create abstractions. Those things, they do technically exist in Helm, but I've never seen anyone actually use them. So that's probably a good sign right there that they don't work too great. So at the end of the day, the current state is that we've got these infrastructure as code solutions that are sort of first-class citizens within Kubernetes, but they're hard to read and they're hard to change and they're very hard to test, which means they're really, really hard to maintain over time. And we've seen a lot of people looking for a better solution for this. And that's where constructs come in and the cdk8s. So the cdk8s is based around this API concept of having a construct, and a construct is just simply a unit of infrastructure. Now, you start off with what we call level 1 or L1 constructs, and these constructs are going to be generated based on the Kubernetes deployment you're targeting, based on custom resource definitions that you've already imported and other things. And we'll talk more about that import process and that generation process here in a moment. But once you get those L1 constructs into your system, then you end up with a completely blank white page. Bear with me for a sec. All right, that's better. So you end up with L2 constructs. Now, L2 constructs take and leverage L1 constructs, but put and provide nice abstractions over top of them. You are generally going to probably be writing some L2 constructs yourself, or you can leverage third-party constructs. There is a side project, the cdk8s, called the cdk8s Plus library. And it's managed by the same team, the same people, but there's a distinction there between the basic API itself and these L2 constructs that you may want to use within your environment. So maybe I have an L2 constructs that is just a nicer wrap around a config map, or secrets, or say the case of a deployment. We'll show you in a moment where you can build an L2 construct of a deployment, and then when it actually goes to render out the YAML, it'll create you both a deployment resource and a service resource along the way and have them automatically wired up for you really easily. And once you get these L2 constructs in place, then you end up with an L3 construct or a level 3 construct. And these things are typically much larger size constructs in terms of the architecture that they represent. They're going to have config maps and secrets and deployments and services and ingresses and all those sorts of things. And I've built one in the past that I use for a couple of basic MERN applications that I have deployed into a cluster that I just called my MERN app. And it does exactly that. It goes ahead and encapsulates deployment services, config maps, everything that I need to spin up a basic MERN app from a very standard template that I've got. All right. So those are our constructs, L1s, L2s, and L3s. And we create instances of these objects. We set the properties on them. We correlate them with each other, setting references to each other. And at the end of the day, what we end up with is essentially a big object tree or an object map. And when we're all done with that, when we're done creating all these constructs, we pass it through a synth routine or a synthesize routine. And what we get out of the back end is standard YAML. So here at the top here, I've created a L2 construct out of the cdk8s Plus library called a deployment, and I set the standard stuff on it, specs, replicas, pod spec templates, those sorts of things along the way. And then when I want to expose this deployment behind a service, then all I have to do is call this expose, give it the port number, and I'm done. And the construct itself has all the logic built into it to know how to create both the deployment as well as the service that ties to it. I don't have to worry about selectors. I don't have to worry about app labels and all those other things. Those things are about the things that are specific to me and not all the Kubernetes wirings along the way. Now, big advantage to this too is that the cdk8s does not have an opinion about how to deploy these resources. All it is a generation framework. All it's meant to do is generate out YAML. What you do with that YAML is up to you. How you fit into your CI/CD pipeline, how you fit it into your normal routines doesn't really change, or probably doesn't really change much from what you're currently doing, because most of the time at the end of the day, you're still dealing with static YAML files.
I got a question, Matthew.
Sure.
I might be stepping ahead, but so I look at like line 6 on the image. If I wanted to, from a reusability perspective, if I wanted to synthesize a new YAML with, or new YAML with a different tag, would I be able to have environment variables that would allow me to switch which version that I'm running?
Right, exactly. Because at the end of the day, we are now dealing with basic OOP concepts, basic object-oriented programming. We create objects. How you set the property on those objects is completely up to you. In this case, it's being set through a static variable. But it would be just as easy in terms of the API to, instead of having that be a static string that says node right here, it be a variable. And that variable gets set from either an environment variable that was provided when the synth routine was called, or maybe because of a static JSON file that I've read into the process and I use one of the values out of that static JSON file as the image name. Or if I really want to, I could also make an API call out to an internal service that defines these things for me, take the results of that API call, and then plug them in for things like image names and tags. And you get to the point where we've really taken the DSL out of these things, out of our infrastructure as code, and giving you a general programming language. So you can do just about anything you want to with some rules in place about how to do it well. All right, so this is that MERN stack that I was talking about before. This was a construct that I built. This is just a basic class. If you're not familiar with TypeScript, that's what I usually write all my code in, is just basic TypeScript. It's very similar to Java or C#. The conventions and the names and everything are a little bit different, but for the most part, if you've read those languages, hopefully this will make sense to you too. So the first thing I do is I create a chart. Now, keep in mind that this is a little bit different from a Helm chart. This is a convention they decided to keep, that a chart represents many, many different types of objects, and it's something that you deploy all in one shot. But at the end of the day, a chart is actually just another construct. There's nothing fancy going on here. Line 2 shows our constructor for this object that I'm creating. And these object constructors are really the basic entry point for all of this. Standard, again, OOP programming here. And every construct is going to have the same signature for its constructor. The first thing is what's called the scope. And this is what we pass in as that helps us build our object tree. So we'll get to that here in a moment. We've got a name, which is just a basic identifier within the entire scope. And then we've got properties that we pass in as the third parameter. So very standard, every construct you see is going to follow the same pattern of scope, name, and properties. Once I get into the constructor, then I use these properties to go ahead and start building out other constructs. So the first one is an issuer. This is coming from the cert manager controller, and a CRD that I imported in that allows me to issue SSL certs for my ingress and things like that. I create an ingress object, which these are all basically L1 constructs that I'm using at this point. So this is pretty much one-to-one with a standard ingress object or resource in Kubernetes. Finally, a deployment in a service. I've left out a lot of the details here because if I left them in, they would probably look very similar to the Helm charts or the Kubernetes resources you've seen before, and I want to kind of shrink this down a little bit. But I build this whole thing out. Now this is a reusable MERN chart that I can use, and if I just extend out the properties on this and add some more properties along the way, like what's the container image that I want to use in that particular situation, then I can just synth this over and over, passing in different properties each time and get as many charts out of it that I want. In this case, this is what the rendered manifest is going to look like. So I get my issuer, I get my ingress, it continues on down along the way. And then I take this and I just use a standard kubectl apply to get this applied against my running cluster. All right. So, why would you want to do this? What are the benefits over the old stuff? One of them, and probably the strongest one, is the multilingual support. Again, I'm not a Go developer, so anytime that I've had to deal with Helm charts in the past, I always find myself reverting back to Go cheat sheets for the syntax, cheat sheets for all of the conditionals and loops and things like that, and usually have to fight it a whole lot. I typically write all my stuff now in TypeScript and JavaScript, so being able to also write my infrastructure as code in that same language means that it's going to be a lot easier for me to do. And at the end of the day, it doesn't really change what you're writing. It just kind of helps you with the syntax and it helps you along the way, because of course we have IDE tools that give us strong strong typing, and all these other things that have really helped us develop application code. Well, now we get to bring all those tools and all those benefits into our infrastructure as code, which we've been lacking over the last few years. Next up, and this one is one of my favorites too, is it's unit testable. Because at the end of the day, when I'm building out a construct, what I essentially have is just standard objects. I can evaluate those things and write unit tests around them to ensure that complicated logic is being executed the way I expect it to. And one thing you've probably noticed if you've ever worked with Helm charts or any other sort of IAC like CloudFormation is that if you start to get into some complexity because you want to make these things really reusable, you develop this MERN application and you want to give your consumers of it the option to say, well, how many replicas do I want in my deployment? Well, that's just a dial that you put on that chart. Well, what happens if that dial starts deciding whether a resource is created or not? What happens if they pass in a flag that says, well, I don't want ingress, this is a private service, so I don't need an ingress route? Well, now you have to test that, which means that in the old style, you'd have to render the Helm chart once and then go out and deploy it and go, well, did I get an ingress? And then you'd have to turn that flag and get the code back out and say, okay, well, did I not get it? Here we can write unit tests, which makes that a lot easier along the way and a lot quicker to get to an end goal with all this. I remember a couple of years ago, I was working with Terraform, and I was a big Terraform fan at the time, but it took me nearly a month to build out a Terraform module that would deploy out Magento deployments for our customers. And it was a very tedious process. And if I had unit testing in place, I think I would have liked it a whole lot better. So what does adoption look like? Let's say so far you're kind of liking what you're seeing. You're thinking, oh, this sounds like it'd be really cool, but what does it actually look like to replace what I've currently got in my Kubernetes cluster and my Helm charts and things like that with the CDKs? Well, there's basically a 4-step process here. And if you click on this link on the slide deck, you'll actually go to a blog post that I did like about a month or maybe 2 months ago now about how I worked this with my own Kubernetes cluster that runs a couple of side projects and things. So the first thing we need to do is we need to define what we're importing and the types of resources we're going to build when we import our custom resource definitions and other things like that. Second step is we take snapshots of all of the resources we already have for a given workload in a cluster. So if I start replacing out, well, my MySQL distribution, okay, so I'm going to go and use kubectl and and interrogate my existing cluster and get JSON files or YAML files that tell me what's already there. I'm going to start writing unit tests that take those snapshots and check to make sure that I'm actually building what I currently have. And then I start implementing the actual construct. And this is a kind of a sort of a typical TDD pattern at this point for test-driven development. So if we break this into a little bit more, so the first step is importing our CRDs. And this file that we're looking at right here in this main panel is the cdk8s.json file that will be created for you when you start a new cdk8s project. And the first line of these imports, line 4, tells us what version of Kubernetes do we want to target. If I put it in just like we have here on line 4, it's just going to go out and get the latest version according to the official Kubernetes deployments. I think 119 now, correct me if I'm wrong. But if I wanted to, I could pin this to a specific version by just saying K8s at 1.15 or 1.16 or whatever. I can point it at publicly available CRDs that I can just hit through a basic curl command type thing, or I can also point it at a local file that's part of the project itself that defines out all those CRDs. And then once I have this, I run an import command using the cdk8s CLI, and it's going to generate out all of the L1 constructs I need to start building out the rest of my code. So next step, going and snapshotting these resources. Again, all I use is kubectl to do this. I go get me my ingress named a specific name, output it to JSON, and then put it in a tests folder that I can use later in my unit testing process. Then I write my unit test up. And the first thing I do is I just import that snapshot as the existing record. I then go ahead and create my new object and synthesize it, and then check to see whether that synthesized result matches up with what my existing resource is. And then I just start implementing. And once I start implementing this code within my construct, I can quickly and easily iterate over it, running my unit test until I basically have a passing unit test. And then I know that at that point, very confidently, that my construct is going to build the exact same thing that I already have out there in the resource. And once I've got that, now I have my unit test in place, and now I can start refactoring. I can start moving things around, and I can start making a more readable code, more reusable code, make things dry, and so on and so forth along the way. So that's mostly it. A few kind of closing notes on it. The cdk8s and the cdk8s plus libraries are technically in alpha. They are fairly stable, but don't be surprised if you see some changes when it comes to the way the library actually handles some of the more edge cases around the functionality. The team that's building it are some of the guys who were working on the CDK. They learned a lot from the CDK, and they took a lot of those things that they learned and they brought them over in the CDKs. So it's still a fairly good API, in my opinion, for where it's at in an alpha state. But just be warned, I wouldn't suggest that you go doing a blanket replacement of everything that you have running in your production environment with this. But certainly start using it on some projects that maybe aren't public facing, something which can handle a little bit more risk than some of your production stuff. And also, it was recently submitted to the CNCF as a sandbox project, which is really cool. Hopefully, we'll get some good support from them, and we'll see that that this thing progresses as it gets worked through that whole process. So that's about it. We're kind of open for Q&A. So let me see if anybody has asked any questions yet. No one's asked any questions. None at all?
I mean, I know we didn't talk about it, but Matthew, can we put you on the spot and see a demo?
Yeah, no, absolutely. I was kind of expecting that. So let's go over here. So let's see here. Resume sharing. Okay, so everybody should be able to see my screen now. Let me see if I can make this a little bit bigger along the way. So this is a brand new project that I created specifically. All I did to get here was I first started off with just this cdk8s init. Let's see if I can make this a little bit bigger too. All right, that should be better. So the cdk8s can be installed through an npm I global cdk8s CLI. This will go out, grab the latest version, install it as a global CLI for your tool. And then if you want to initialize a new project, you say cdk8s init, and then you can choose Java, Python, or TypeScript. We can talk here in a moment if you're interested about the JSII. The JSII is the underlying library which powers this entire multi-language functionality. And right now, what the cdk8s supports is Java, Python, and TypeScript. It does not support .NET yet, as the rest of the AWS CDK does, but that'll hopefully be coming somewhere down the line as well. So this is a brand new project. I just created it. So the first thing that it has right here is just simply imports of just the K8s resources. And if I go in here and I take a look at my imports directory now, I can see that I've got this one big giant k8s.ts file that is going to have all the goodness of things like a deployment. And a deployment is an object, a construct that I can use to then build out the rest of the stuff. So let's actually go try that. Basic boilerplate code right here. At the end of the day, the cdk8s doesn't really do anything magical when it comes to synthesizing. It all just executes this main.ts program for you. In fact, you can see it defined right here. We're saying that this main app in this cdk8s project is just run this node main.js command, and that's it. So I've created a class here called myChart. It extends from this thing called a chart. I have my basic constructor lined out in place. Once that is defined, I create a new app. We'll kind of come back to why we have this wrapper of an app, because I haven't talked about it before, but we have an app. I create a chart handing the app as its scope. So the app is always at the top of my object tree, and then my chart's going to be the first thing underneath it. And I just simply call this chart KY cdk8s. And then I run the synth command. Now, if I do this and I go ahead and say, run my synth here, what's actually going to get generated here in my dist folder is nothing, because I haven't really defined anything yet. I technically have defined a construct called a chart or a my chart, but I haven't really put anything into it yet. So let's actually go ahead and do that. And let's start with a new config map. So we'll bring this in from just our K8s imports at this point. Scope, I'm going to give it as this. And this is a very typical pattern. Typically, when you're creating new constructs, you're doing it from within a construct. So you always make that construct the parent of the one you're creating. And we'll say this one is our, let's call it the Nginx config. And then we have options. Now, again, we get strong typing at this point because these are just TypeScript objects. So I know that I can provide binary data, or metadata along the way. So I'll just go ahead and provide it some basic data. Hello world, and that's about it. It's giving me a big old warning that I probably don't have enough of it defined. So I'm going to cheat. Maybe I can cheat. Let's see here. Our string type data is not assignable to config map options. So let's see if we, oh, here's why. So data is not actually a string. It is an object. So we'll say hello world. All right, cool. All of our red squiggly lines have gone away. We know that we have correctly typed out all of our code. So I'm going to go ahead and resynth this. And now, I think I forgot to build. Because it's TypeScript, I always got to recompile my code. I'm not quite used to that yet. Ooh, we got a test failing. So this is really cool. So I went ahead and I implemented this code, and then my unit test starts failing. Well, that's because my unit test is actually expecting no resources to be defined. I'm going to cheat here, and I'm just going to get rid of this for now because I don't want this to hold up our work. So,
okay, I wouldn't accept your pull request.
Well, and that's fair. That's that's one thing we absolutely should be doing along the way. We should be accepting code that isn't unit tested. So our tests fail, but that's fine. I don't really care. And now you can see here we have a config map resource defined out with our basic hello world along the way. And I can keep doing this. Now that I have my config map, maybe I want to go ahead and create a new deployment. And when I do this, we'll say this, we'll call that the app. And now again, I get all of the type safety and nice things along the way to help me build all of this out. So even if I don't know exactly what goes into a deployment, well, I can just basically start looking at this and kind of figuring out what's going to go into it. So I know, well, I got selectors, I got replicas. Okay, let's make this a 3 replica setup. And let's go ahead and put in here our pod template, and so on and so forth. So I just keep working through this, keep filling these things out along the way. In a lot of cases, you can actually take your existing resources, if you have snapshotted them out to a JSON file, you can actually take those things, copy and paste them right back in here to the props of the deployment, and it just works. Because this deployment object that I'm working with right here is a one-to-one generated resource from the underlying Kubernetes resource definition. So it will be just mostly a copy and paste job. But once you've got it in here, now again, you can do unit testing on these things. You can do refactorings. You can pull common abstractions out into other constructs and other classes along the way. In fact, a lot of times it's usually recommended that you don't create L1 constructs directly within a chart. You want to have them within their own construct, so that as versioning changes and certain field definitions may change, that you can abstract those away properly from your consuming code and that sort of stuff. So we can keep digging through this if you want, but hopefully at this point you kind of see the pattern of you can very quickly get this thing up and running and start testing all this and have some good stuff to find. And then again, if I wanted to take this resource and apply it, all I do is just kubectl, apply -f, and then dist. There we go. All these resources would be then deployed out to my Kubernetes cluster, which I'm not going to actually do because that would be kind of painful for me right now.
So Matt, I saw that you were defining a few different resources in that level there, and you were saying it was kind of a copy paste job at that point. And you would move them out to their own constructs eventually, and that's where you get the benefit. So would the end result of, say, just imagining what this my chart section could look like, it would be like new queue consumer, point to this code over here, and it's just like a few lines to
right. And then this queue consumer is a class that I would create, that I would put, a stateful set or whatever it may be in there, that I'd wire up, and I would make it in such a way that that queue consumer and these properties that are passed in, I don't really have to know much about the underlying Kubernetes. I can just know things that are important to my application. Like, okay, what is the queue that I'm listening to?
Yeah.
But, yep.
When defining those, right now you're just newing those up. Is there a way to kind of share bits of data between them? So if like one depended on another?
Yep. Yeah, so actually, let's say we've got this config map right here. Now I'm creating this new object. I'm not really saving a reference to it, which means I can't reuse any of the things that are important to it later. But that's easy. I just say, we give it a name. And then down here within these things, let's say I'm down in my pod spec now, and I'm defining things like containers. I'm going to do a new container. Actually, I don't think I need a container object. Yeah. So now I'm kind of at the stage of defining my containers for this particular deployment. And I've got like an image that I'll give it, and I've got environment variables. So in this case, I can say that my environment variable is going to be just simply a name of source queue. Actually, let's give it a better name, source queue. And the value is going to be something from nginx config dot, whatever. This case, I don't really have anything off of that config map object that would be useful in this case, but let's assume for a moment that this was our source queue dot queue name. All right. And source queue, I'll say, is a new queue called my queue. All right. So I create these objects, and if I want to have a value that's particular to one type of resource carry over and be available in another type of resource or construct, then I just pass value references back and forth. No fancy string concatenation or magic referencing values. If you worked with CloudFormation, you may have worked with like import value and export values before. Those generally are no longer concerned. I just pass objects around, and I just create this tree of things that have references to each other, but that's it.
Man, that's really awesome. From a development perspective, just imagining not knowing much about Kubernetes, and I can pick one of these languages. Yeah, it does seem like you can churn out something really quick.
Yeah, so let's go take a look real quick. I want to show you some of the, gosh, I think it's plus. No, not global. Dang it. It's a bad habit. Okay, so I'm going to go and install the cdk8s plus library, which is going to give me some of these higher level constructs, these L2 constructs that simplify this a little bit more along the way. So let's get rid of all this, and we'll say, give me a new deployment. And this time, I'm going to actually take it from the cdk8s plus library. Now, first two guys are always the same type of parameters, but now we'll start to see that when I get into the spec, then I've got some slightly different things in here. Notice how I don't have nearly as many parameters that I'm having to find along the way. It's sort of abstracted a lot of that away, so I don't have to really care about it. I can define things simply as replicas. I can say, here's my pod spec template, and provide all those things in there, and they're all wrapped up in an easier to use interface, easier to use objects. And when it's all done, like we saw in sort of the early example, if I want to now expose this deployment as a service, I just sit here and provide some of the parameters, a port type and a service type. And notice here how, because again, we get strong typing, we get enumerations, we get things like that, I no longer have to worry about putting typos in when I type in load balancer. I know that I can just go ahead and putting these guys as is, and it definitely simplifies and keeps a lot of those nasty problems away. For example, today, typos lost us about 4 hours of development time because we weren't noticing the difference between a .yml and a .yaml. So we had 2 different ways of handling a YAML extension, and 3 of us spent an hour and 15 minutes before we noticed that problem.
I've been
debugging
there so
everything
much.
else. Right.
We literally just debugged a Helm, Jason and I. It took us about an hour to realize in his Helm command that the environment variables in the pod spec did not have a dash in them. So I completely understand what you're talking about when you're coming from.
Right. So, you know, one of the primary goals of shifting to a framework like this is that you can hopefully eliminate those types of really painful problems, because those are the things that are going to make you really gun shy to change a Helm template in the future. So you look at it and you go, oh, yeah, we got this Helm template, and we got this one of our app teams who, you know, wants one small change to it. Well, I mean, I can make this change, but I hope I do it right, and maybe I'll spend like an hour and a half doing it, or maybe, you know, I'll break it for everyone else along the way, and that's not good. So why don't we just copy and paste, and then we know we reduce the risk for all the other teams, and now this other team has got a whole separate template that they got to, you know, manage, and there's no sharing between them. But you end up going that route because it reduces the risk, and there are times where reduced risk is more important than, you know, wasting a couple hours later, those sorts of things. And one of the things that's also really cool about this is that because these things like deployment here and the cdk8s plus library, these things are standard NPM modules, Python modules or Python packages, and Java packages and things like that. You can distribute them the same way you distribute all the rest of your dependencies and library code and things like that. So what we're doing at our organization is that we've got a project type that we want to deal with a lot. So we have a bunch of different accounts that we're managing, and we have an AWS CDK project. And we have a basic boilerplate for that project that we wanted to distribute to everybody. Now, we first started with the process of having a Git repo, and we'd say, just clone this repo, or fork the repo more appropriately, fork the repo, make whatever changes you need to in your code, and you're generally done with it. But that's also introduces problems. You're copying and pasting effectively, and long-term maintenance can be very problematic. One of the other projects that came out of this construct API idea was a project called Progen. I'll type it out here because it's Progen. Progen is also developed by one of the guys who was on the AWS CDK team. And Progen is a construct-based API for generating projects. So in a API that's very similar to this, where I have constructs that I build, I create these things along the way, and then when I run a synthesize routine on my Progen file, what gets spit out is package.json, an npm ignore, a git ignore, jest config files, ts config files, and boilerplate code samples spread throughout directory structures as I define them. And those things are continuously managed. It's not just a copy, it's not templating. It's those things are generated files that are managed by Progen. So if I need to change and add something to a git ignore file, I'm not changing the git ignore file directly or the npm ignore file directly. I'm going back to my Progen and I'm adding these things in there. Well, now it means that if I want to take this package, this CDK project that was all this boilerplate code, and I want to ship it to a bunch of different accounts, I'm not shipping a Git repo that is cloned. I am shipping an API object through NPM. And then I say, okay, just create a new one of these objects, synthesize it, synth it, like you do everything else, and boom, you have your project type ready to go. And you can modify it all you want, because if we decide to make a change later on, that change naturally integrates into all of the other projects very, very easily, versus templating, which that very rarely works well.
It seems like a little bit of inception, but I understand the pains from distributing, clone this, but reset the history, do all that, and those sorts of things. Are you finding that distributing, so you use Progen to kind of to bootstrap your own template, and then you publish your own version to your own internal artifact, like artifact storage for others to depend on from there? Are you finding that to be good in the long-term maintenance kind of posture with that, or has that manifested other problems along the way?
That's a good question. Based on what I know of the project, and I just want to bring up the page here so you can kind of see some sample code a little bit better. Based on what I've seen so far, and this is real early, keep in mind, I think Progen was originally published probably 2 or 3 months ago. Looks like initial commit was 5 months ago for this. Still very early days, but I see it as being very beneficial, and I think it's going to really help us long term with those things. So here's an example. We can talk about it if you want to, a JSII project. So if you are going to create one of these constructs, if you have an AWS CDK construct or cdk8s construct, or anything else that, any kind of construct that you want to create and make available in multi-languages, then you build that using the JSII. So you write everything up in TypeScript, and then you hand it over to this thing called the JSII, which then generates the code for Python, Java, .NET, and otherwise for you. So then you just package that and ship it as is. So this is a case where this is an example of creating a new JSII project so he's got his author address in here, his author name, his project or his package name, and a basic repository. He synthesizes it, and what gets spit out is all of the files necessary to basically bootstrap up one of these new types of constructs to build with. And he's got project types in here for cdk8s constructs, AWS constructs, and AWS app. If you're building Next.js projects, this is a project type for Next.js. So rather than worrying about using the templating that comes with Next.js, if you want to, you could use this to spin up a new Next.js project along the way. And easier to maintain that project over time as well. So very cool project, yet another. So that makes, let's see here, we got the AWS CDK, the cdk8s, the Terraform CDK, Progen, and then CDK Day 2 weeks ago, we had a gentleman from Microsoft showing up a prototype for the CDK for Azure. And I suspect that we're going to see more and more of these things spin up over time, because the API has proven itself to be very simple to understand, very simple to build against, but very powerful in terms of what you can get out of it. It's actually very similar in React in that sort of situation. One of the reasons why React has been, it's sort of the de facto UI framework for the last few years, is that the very simple concept of a component. A component and a construct share a lot in common. A component in React is entirely, or should be entirely, self-encompassed. It should be something that you can ship it around to everybody you want, and it's going to behave the same way every time. It doesn't make any assumptions about the rest of the code that you have in a project. Same thing with constructs. In React, you build up this basic object tree that represents your UI, where you have a sort of a layout panel in the beginning, and then you drop a couple of children in there for like a header, a footer, and a content pane. And then that content pane, again, breaks down in more and more children. same concept in the situation here with the construct API. So very cool thing there. Definitely recommend you check it out. If you have to spin up or manage a lot of NPM projects or other types of projects, it's definitely worth looking into. The JSII too is actually also very cool. This was, excuse me, the JSII was built by Amazon specifically to do this multilingual generation. And there's actually been uses of it already outside of just the construct world. So there was a package or a library I saw someone build a few months ago that he used internally at his company because they were running some pretty legacy systems where timestamps in the system were non-standard type. So he built basically a string parser in a JSII construct, or excuse me, a JSII project, and then had that automatically compiled to Python, Java, and C#, so that no matter which application team he was trying to parse this type of timestamp, they could have a common library for doing it that they knew was tested and correct and verified on a regular basis. And I apologize, my dog barking in the background. He gets really worked up right after he eats dinner. Likes to bark a lot, so.
I figured he was getting worked up over the custom date strings.
He's a big fan of not having to write a lot of code himself.
Oh, we all.
Right. So, this is definitely kind of rambled into a couple of various trails and things. I don't want to take up too much more, but that's, the CDK8s, the whole suite of CDK style projects and things like that. Like I said, as far as the AWS CDK goes, I know we didn't talk about it a whole lot, but that's a project and a development tool that has been crucial to my career over the course of the last year. And there were certainly things like managing 30 different MySQL database instances within one environment, and I had 7 of those environments to do. So, yeah, over 200. I think at one point we were peaked over 250 different MySQL databases running in one account. And I could not have managed all of those things if it hadn't been for the CDK. So I'm a big fan of it, big push. I don't work for AWS. I'm just a fanboy. But I like the CDK8s a lot. It definitely allowed me to get out of the hell of Go templating and Helm charts and things like that. And I look forward to some of the other stuff that they come out along the way. There was actually a great question the other day. Someone was asking if there was going to be a construct API built or a CDK built to handling Docker. And we said, well, how exactly with Docker? And they said, well, we want to handle, generating Docker compose files. And at the same time, someone else said, well, I want to generate Docker files themselves by using constructs. And it's already kind of opened up this interesting discussion that spawned out of that of, well, could you actually generate a Docker file or synth a Docker file based on constructs that were being built? And I don't know if it will ever come to pass, but it was sort of an interesting idea. And, it's a generation framework at the end of the day. The Terraform CDK is a really cool one. As soon as that happened, then I figured, okay, this has kind of hit mainstream. We've now got a case where I can use constructs and I can use this TypeScript or JavaScript or whatever I want to build out all the Terraform that I want, which means I can leverage all of the Terraform providers that already exist, whether it be for AWS, Azure, GitLab, GitHub, any of those things. So it's going to be a really powerful tool, and I can't wait to see where that project in particular goes over the course of the next year. All right, any other questions from anybody?
I now know that I've got another tool on my list to go test. Good thing I'm not busy this weekend. Oh,
before I forget, there is cdk.dev. If you go to the cdk.dev website, there's a link on that website to a Slack channel. And that Slack channel is dedicated to all things constructs, whether it be the AWS CDK, the CDK8s, the Terraform CDK project, any of those projects, there's a channel for them. And it's getting pretty active. The last time I looked, we have almost 900 people on the AWS CDK channel, and we have some active conversations that help hitting the other ones. So if you do look into these things, please come reach out to us on the Slack channel. We're over there actively trying to participate and be helpful.
Yeah, I can second that. It's been a great community over there, and it was great to use that as part of CK Day a couple weeks ago. And something that I just seen recently that kind of relates to what we're saying tonight is that all of these will actually interop pretty well together. I think they just released the AWS CDK being able to interop with CDK8s so that you can actually define on both sides your infrastructure in CDK and then your actual deployment manifests and such in CDK8s. So CDK all the way down, right?
Yeah, which is really great. In terms of when you think about, who is going to be managing a lot of the infrastructure. So if I'm a DevOps engineer and it's my job to make sure that there's an EKS cluster running and that EKS cluster is manageable and maintainable and accessible and is set up and ready to go for anything the application teams toss at it, I'm probably installing a few things to it myself. I'm probably installing some CRDs. I'm probably installing some controllers and other things like that. And to be able to do that all in one place and not have to skip back and forth between multiple pipelines and multiple things to get that all happening is really, really cool. And that is a very recent update. They actually have supported giving it static manifest files for a while now, but they recently just jumped the hurdle where you could hand it an actual cdk8s chart itself. And the big thing around that was the idea of tokens. One thing that happens a lot when you're dealing with these references and all these things that are created. So a few of you mentioned some AWS CDK familiarity, and I kind of assume there's a little bit of AWS familiarity here in general. But if I go create like an RDS instance, or database in AWS. One of the things that I probably care about at some point or another is going to be a URL or a host name for that server that I can hand to my applications for connection strings and things like that. Well, that's a value that's going to be generated probably, which means that when I'm actually going through and defining these things, there aren't hard values that I can reference, and they end up getting tossed into some tokenization framework. And it was that fix around the tokenization framework in the CDK8s versus the tokenization in the CDK that they finally fixed. So now I can sit there and say, here's an RDS instance that I create via the CDK, and now I'm going to pass a reference to that to my chart so that its host name can go into a config map or into a secret or into an environment variable for a deployment or any of those sorts of things. And it's all handled pretty seamlessly. I haven't had a chance to play with it yet, but I think it's going to be really promising and very, very cool. All right, well, thank you very much for having me. It's been a pleasure to come and talk to you guys. Please reach out to me on either Twitter or on to that Slack channel if you have any other questions or if there's anything else I can help with along the way.
I think the only last question I have, well, you got your Twitter handle. Do you mind if I post your email? That's up to you. I always ask before I post the email speakers.
No, I don't mind an email address being posted. Google's good enough about spam that I'm not worried about it.
Okay. All right. Well, I posted the link to the CK8s app repo. I posted the link to your presentation, and
cool.
Yeah. With that, if no one else has any questions or comments that they want to talk about, I think we can now wrap up for the evening.
Yeah, I just want to thank you both. And this is Dave Cruz, Matthew and James. It was very good listening to it. So thank you very much.
Good. Glad you liked it. Thanks, David.
Yeah, thanks for coming, David. All right, well, I'll get this posted as soon as possible, guys. And Matthew, I'll follow up with you because I don't think CJ told you I like to bribe my speakers. So.
Oh, fantastic! I'll always take a bribe.
Yeah. All right, guys. Thank you again, and I hope
Thanks, everybody.
to see you next month. Bye.